The last time we discussed multiplying polynomials, we went over the area model, which is sometimes known as the box method. So this time I would like to show you another way that problems are presented. So if you are given a picture of a shape, or typically it's a rectangle, it may ask you to find the area of that particular figure, whatever figure you're working with. So what you need to do first is identify, well, how long is the length and the width of it? Because remember, for the area of this particular figure, which is a rectangle, the area formula is area equals the length times the width. So it doesn't matter which one of the binomials that I take first. What does matter is that I have an operation in between the two. So in geometry, you learn something called segment addition postulate, where you have this part of the segment plus this part is equal to the entire thing. So what I said is addition. So I am going to add those two together. Pay attention to that, because sometimes the problem will not give you the sign. You just have to know to add that sign there. So 3 plus 2x. This is important because, as I stated, in the area formula of the rectangle, you're going to multiply the length times the width. So this is really 12 plus x times 3 plus 2x. I personally like the box method, so that's how I'm going to set it up. I draw my box, and it does not matter which one goes across the top, but I'm going to take that first one, 12 plus x, just the way that is shown in the problem, and then 3 plus 2x. And now I'm going to fill in what I know. 3 times 12 is 36. 3 times x is plus 3x. 12 times 2x is plus 24x. And then 2x times x is 2x squared. Now what I want to do, if possible, is combine like terms. So I do see that I have two boxes that have an x in it. So I want to go ahead and combine those, which leaves me with 36, if I'm going in order. 36 plus 3 plus 24 is going to be 27x. And then my last term is 2x squared. However, you do not leave your answer in this form. You always put it in standard form, which means your leading coefficient and exponent, sorry, my highest exponent should go first. So 2x squared plus 27x plus 36. This is the area of this figure. Now, working backwards, if I were to give you this trinomial and ask you to factor it, those are the factors. So, well, it's kind of hard to put the factor around that. But again, those are the factors right there. So you're doing the inverse. That's all you're doing. Pay attention to the terminology. Here it asks for the area. So the next one, I am asking for the perimeter. The perimeter simply means that you're going to add all of the sides together. So there's more than one way to do it. You could actually just take, well, if you know the characteristics of a rectangle, you know that if the top length is 12 plus x, so is the bottom. And the same with this side, if it's 3 plus 2x, so is this other side. So you have two of the same values. So here I'm going to write 2 times 12 plus x. And I'm also going to write 2 times 3 plus 2x. And for those people who like to distribute, this is what you're doing. You're going to distribute, and then you're going to take those answers and you're going to add them together. So 2 times 12 is 24, plus 2 times x, which is 2x. 2 times 3 is 6, plus 2 times 2x is 4x. Take this answer, 24 plus, because you're adding all the sides together. That's what perimeter means. So 24 plus 6 is 30, plus 2x plus 4x is 6x. So this is my perimeter. Okay. If you were asked to write it in standard form, you would just put the 6x first plus 30. Now on this one, you still have a rectangle, but it's presented a little different. This time it's showing, it doesn't have it broken apart. It actually shows you the operation of the plus sign that's in between them. But you're going to do the same thing. So you're going to set up your box, or you can just use your distributive method. I prefer the box. That's why I use the box. And then I'm going to, at the top, do 2x plus 5. On the side, 3x plus 4. 3x times 2x is going to be 6x squared. 3x times 5 is 15x. 4 times 2x is 8x. And 4 times 5 is 20. So again, I know that I have some x's that I can go ahead and combine those together, which will leave me with 6x squared. 15 plus 8 is 23x plus 20. This is my area of that rectangle. If I'm trying to find the perimeter of that same area, same rectangle, then I am going to add all of the sides together. And you may say, but I only have 2 of the sides. You have actually all 4, because again, 3x plus 4 is the same on the bottom as well as on the top. 2x plus 5 is the same on the left-hand side as well as on the right-hand side. So some people don't necessarily like to do the method I just showed you a few minutes ago where you take 2 and multiply it. Some people literally like to just add. So that's what we're going to do. We're going to take 2x plus 5, and then we're going to add it to another 2x plus 5. Then we're going to take that 3x plus 4 and add it to another 3x plus 4. But understand, it means the same thing as 2 times 2x plus 5 and 3 times, 2. I do that all the time. Let's go back here. 2 times 3x plus 4. Now, I cannot write 2x plus 5 squared. That is incorrect. So make sure you know that you cannot use a square. Okay, so going back to solving the problem to find my perimeter, now I just add vertically. 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 3 is 10. 5 plus 5 is 10, and then 10 plus 8 is 18. So this is another way to find the perimeter. But again, if you were to actually do the math this way, you're going to end up with the same thing. You'll just have 4x plus 10, and then you'll have 6x plus 8, which results in 10x plus 18, which is the same thing. So it just really depends on how you want to do it. That goes here, and this goes there. Again, make sure it's a big 2, not the superscript, because some people get confused with that. But those are ways to actually multiply polynomials. They just show you shapes instead. You know the routine. Okay, take care. Have a good one.